In this video, we are going to show you how Snowflake Multi-Cluster Shared Data Architecture allows running both your ETL and online query workloads at the same time using two separate virtual warehouses. To execute the query workload, we are using JMeter, which emulates 10 active users issuing queries back-to-back against a 10 terabyte sales database. You can see the throughput is relatively steady at about 10 queries per minute. For this demo, we will run the ETL script from our web UI, but the same script can be executed from our command line client. First, we log into Snowflake as the ETL user. The session begins on the Warehouses page, where virtual warehouses are managed. The first virtual warehouse in the grid is named Analytic Warehouse. It is a large 8-node enterprise warehouse. Enterprise nodes have extra memory and local storage and are better suited to run large numbers of concurrent queries. We see that the Analytic Warehouse is running. This is the warehouse executing the queries issued from JMeter. The second warehouse is named ETL Warehouse and is the warehouse we will use to run our ETL script. This warehouse uses standard nodes, which are cheaper than enterprise nodes because standard nodes use less memory and local disk. But the ETL warehouse is extra large with 16 nodes, twice the number of nodes in the Analytic Warehouse. The ETL process is single stream and will benefit from this bigger cluster of cheaper nodes. ETL Warehouse is suspended right now because we have not yet begun to run our ETL. While suspended, a warehouse has no compute nodes, so there are no runtime charges for it. Let's switch to our database management page. Like warehouses, you can have as many databases as you want, and a single SQL statement can reference tables in any database. Here is the sales database we are using for our demo. This database is 10 terabytes of raw data and is accessed by both query and ETL workloads. Now let's switch to the SQL worksheet to load and run our ETL script. Remember that our ETL warehouse is suspended. So the script resumes that warehouse and uses that cluster to run the ETL job. The script executes all DMLs in a single transaction, which is committed at the end. When the transaction commits, all changes it made will be immediately visible to any other query in any other warehouse. Where these queries are running really does not matter. Our transaction model is global, as in any transactional system. So let's start our ETL job. When the job begins, we see the statements executing in our worksheet. But let's switch to the History tab to get a bigger view. Notice that the ETL and analytics workloads are running in separate warehouses. The two workloads are not contending for resources. Here, for example, is one of the copies from our ETL job. Notice that the ETL workload begins with a series of copy statements. Each copy loads data from a staging area into a corresponding database table. The staging object, sales stage, contains the S3 URL and AWS credentials for the S3 staging bucket. That S3 URL is extended with a subfolder name, and all files in that subfolder are loaded. The file format object, sales.csv, contains the parsing rules for this input data, including delimiter, quoting, number of header lines, date and time formats, among other attributes. Once the copy statements finish loading new sales data, the ETL workload goes on to refresh a series of aggregates and reports. Each aggregate table is truncated before being recalculated. Our query workload in the Analytics Warehouse continues to run with consistent throughput, despite the ETL workload running in the ETL Warehouse. Not only are these two workloads not contending for compute resources, but because DML statements are not blocking reads, The analytics queries have no performance impact on the copy statements or aggregation queries in the ETL workload. Let's look again at our History tab. As expected, we have our 10 queries executing from the 10 users emulated by JMeter, plus one DML statement being executed by the ETL user. The emulated BI users are still not experiencing any throughput impact from the ETL workload. The ETL job continues to refresh those aggregate tables. Since there are quite a few more to execute, we're going to pause the video here. Okay, we're back. At this point, the ETL process has terminated. It took less than an hour for it to load 1 terabyte of new data and refresh 16 aggregates from the sales database, which is now 11 terabytes in size. Running the ETL process in this example costs about $32, since we were able to suspend the ETL warehouse as soon as the ETL finished. Running in a separate warehouse also allows you to only pay for resources when they are needed. As you can see from the JMeter graph, query throughput has not been impacted by the ETL process. This concludes our demonstration. Thanks for your time and interest in Snowflake.